If the radius of a cone increases at the rate of 3 feet per hour, while the height decreases at the rate of 2 feet per hour, at the instant the cylinder has a radius of 6 feet and a height of 12 feet, find the rate at which the volume changes. It's best to write down the information given here. First of all, the rate at which the radius is changing, r prime, or dr dt, is given as increasing, therefore positive, and a rate of 3 feet per hour. The rate at which the height is changing, h prime, or dh dt, is decreasing and therefore negative and a rate of 2 feet per hour. We also have that the radius is 6 feet and the height is 12 feet. We want to find the rate at which the volume changes. That will be v prime. V is related to the radius and the height for a cone by the volume formula of 1/3 pi radius squared times the height. The radius and the height are not related here. They're independent, and therefore the right side will be a product rule for the derivative. We have the related variables equation. To find the related rates equation, we're going to take the derivative with respect to time of both sides, indicated by a prime on both sides. Every variable is implicit with time. Every variable will have a prime in its derivative. On the left side, the derivative of v will be 1, but then times v prime for the chain rule. On the right side, we have the product rule of 1/3 pi r squared times h. The derivative of 1/3 pi r squared is 1/3 and pi r constants. Bring the power down, leave the inside alone, subtract 1 from the power, and then multiply by the derivative of the inside to complete the chain rule. Times the second left alone, then plus the first left alone, 1/3 pi r squared, and then times the derivative of the second. The derivative of h is h prime. We can simplify this before plugging numbers in. The first term, the 1/3 and the 2, can multiply to become 2/3, and then pi, and then r prime, and then h. And then the second term is simple enough as is, so I will leave it alone. Let's plug some numbers in here. v prime will equal to 2/3 times pi times r, 6, r prime, 3, h, 12, plus 1/3 times pi times r squared, 6 squared, times h prime, -2. So v prime equals to, the first term, we can cancel one of the 3's, or anything divisible by 3 with the 3 in the denominator. I'll just take the 3 out in the numerator with that denominator. Everything's multiplied in that numerator. That will make our numbers smaller here. We have 2 times 6, which is 12, times another 12. That's 144. So that first term is 144 pi. The second term will be a -2 can move out front with the 1/3 and become -2/3. And then 6 squared will be a 36, and we also have the pi. The 36 and the 3 can reduce because the 3 is in the denominator, leaving 12. Therefore, v prime will be 144 pi minus 2 times 12 minus 24 pi. We can now combine those together. 144 minus 24 is 120 pi. Therefore, our rate at which the volume changes, v prime, or dv dt, equals to 120 pi. By being positive, it's apparently increasing here. And it will have units of volume, which is length cubed. Length in this problem is measured in feet, so feet cubed per time. Time in this problem is measured in hours. 120 pi feet cubed per hour.